All right, guys, so this is going to be a quick lesson on balancing chemical equations. Don't forget, at any time you can pause it and work through it. So even right now, what you need to do is write down these three problems on a piece of paper. You can write it on the back of the worksheet you got today, okay? You could write those problems out, pause it, try to work them out, and then check your work after I work through them. That's what I would suggest that you do. Try to work through it on your own, and then watch me work through it, and then remind yourselves or try to figure out what you did wrong or what you did right. So first thing, when we're talking about balancing chemical equations, we have to be able to identify the elements. Remember, every capital letter is a different element. So you have two capital letters in this chemical formula, and this is carbon, this is hydrogen. The subscript tells you there are 4 hydrogens. Since there's no subscript for C, we assume there's 1. This is O, this is oxygen, so there's only 3 elements in this equation. And if you look, we have the same elements to the right: carbon, oxygen, and hydrogen. Now what we have to do is balance the chemical equation out now. Now, if we just did a quick count, on the left I have 1 carbon, on the right I have 1 carbon, so that looks good. On the left I have 4 hydrogen, on the right I only have 2. On the left I have 2 oxygen, and on the right I have 3. So what we have to look at now is, how are we going to fix this? Well, if we can not do anything to the carbon, that would be great, because there's 1 on each side. So the carbon's already balanced. The hydrogen and oxygen are not. So the easiest thing to do is try to figure out if I put a coefficient, and a coefficient is a number that goes in front of a chemical formula. So if I put a 2 right here in front of H2O, I have 2 times 2, which is 4 hydrogen, which matches my 4 hydrogen on this side. And then I have 2 times 1 oxygen, because if there's no number there, we assume there's a 1. So I have 2 oxygen in the water molecule and 2 in the carbon dioxide, for a total of 4 oxygen on this side. Now this is a really easy fix, because all I have to do is put a 2 in front of the oxygen molecule on that side, and now I have 2 times 2 is 4. So now that equation's balanced. Now, remember, or something you may not know, we can't change this number, the subscript. That's what gives a chemical property or chemical formula its properties, is how they're arranged. So we cannot change the subscript numbers. We can only put coefficients in front of the formula. So make sure you guys talk about that with your partner. All right? Now, go ahead and pause it if you want to work through the second problem on your own, and then unpause it if you to double check your work. You're not going to learn anything if you don't make mistakes. On the second formula, you have silver and iodide. So this lowercase letter is part of this formula, or part of this element. A, lowercase g, that's what makes it silver. I is iodide. Then you got sodium, and then you have sulfur. If you look on the same, or on the other side, you have the same elements: silver, sulfur, sodium, iodide. So now what we got to do is we got to count them up and see if we match. 1 silver on this side, 2 silver on that side. So we already can't work with that. I have 2 sodiums on this side, 1 on that side. That doesn't work. And I have 1 sulfur on this side and 1 sulfur on that side. So the sulfur matches up and the iodide matches up. Now, since I have 2 silvers on this side, what I want to do is just go put a 2 right here in front of that silver. And that fixes my silver problem. What it doesn't fix is now I have 2 iodides. Here's the cool thing. I have 2 sodiums, and over here I have 1. So I need to fix that problem already. So now the equation is balanced. If I go back through and count all the elements individually again. And remember, this deals with the law of conservation of mass, right? That says we cannot create or destroy atoms. We can only rearrange them into different molecules. So law of conservation of mass. All right, one more problem before I turn you loose. So we have the molecule. Okay, so for this last problem, we have nitrogen and hydrogen and oxygen. So you got 3 capital letters, which means 3 elements. Same elements are on the right side. Always double check that to make sure you're not putting new elements in there, because we can't do that. So I have one nitrogen, happy with that. 3 hydrogens, 2 hydrogens, not happy with that. 2 oxygen, 1 oxygen. So this one's gonna be tougher to balance, and I'll tell you why. What we try to do is find the least common factor. So in the case of hydrogen, the least common factor would of course be 6. So if I put a 3 in front of the H, with 3 times 2 gives me 6 hydrogens there, and a 2 in front of the NH3 or ammonia, 2 times 3 gives me 6 hydrogen there. So it also gives me 2 nitrogen here, and then I would have to put a 2 here. But the problem is, if I put a 2 here in front of this nitrogen, that would give me a total of 5 oxygens, because I have 3 oxygens already here, 3 times 1. 3 oxygens here, and if I put a 2 here, that gives me 5. And there's no way to get 5 oxygens out of this molecule. I need to have an even number. So 3 and 2 don't work. So the next least common factor between 2 and 3, it would be 12. So here I got to put a 6. 6 times 2 is 12. Over here I have to put a 4. 4 times 3 is 12. Now, what I can do is put a 4 in front of the N here, and my nitrogens are balanced, my hydrogens are balanced. Now I have to balance my oxygens. To do that, I see I have 4 oxygens here and 6 here. 6 times 1, so 6. That gives me a total of 10 oxygens on the right, and all I have to do is put a 5 in front of that O2 molecule, and now that's balanced if you count all the atoms out. All right? Now remember, just double check your work through these problems. Also a reminder, with about 15 or 20 minutes left in class, get your book work done. I do want you to work on these law of conservation of mass problems and get as many of them done as possible, but with 15 or 20 minutes, stop what you're doing. If your book work's not done, get your book work done, because first thing Friday, I'm checking your book work, and if it's not finished, you're on the no-go list. But this is how you balance chemical equations. This is how you conserve mass. This should be really good practice. Again, pause it along the way. You can rewatch this as many times as possible to help you out. Do not let different symbols intimidate you. It's the same math all the way through. Good luck.